All right, final exam cheat sheet picking up right now with problem number 10. Actually, the next three problems that we're going to fit into this clip are all going to come from the same chapter and section, 9.6. Chapter 9 dealt with right triangles, like we see here in this diagram, right triangles and a subject called trigonometry. Trigonometry is highly, highly valuable in the geometric world for simple reasons, that it helps us to solve with given very, very minimal information, but it also helps relate between two seemingly different subjects, angle measurement and side length. And there's some general understandings we'll have, like the bigger an angle is, the longer the side that's opposite it in a triangle, and those sorts of things. Those are simplified fundamental concepts. But in trigonometry, we can actually quantify it. We can actually use a given angle measurement in a right triangle to figure out specific length opposite that angle and everything around that triangle. So the next three problems, numbers 10, 11, and 12, are all going to be based on the same right triangle on your final exam. This diagram right here is taken from our Chapter 9 notes. And so in the next three problems, you'll be asked to identify for missing pieces in the given triangle. Okay, this is known as solving a right triangle. And that was the subject of Chapter 9, Section 6. Chapter 9, Section 6, again, dealing with solving a right triangle. What does it mean to solve a triangle? Solving a triangle in general, there are technically 6 measurable aspects to a triangle. There are 3 side lengths to the 3 sides of a triangle, and then there are 3 internal angles to that triangle. In your final exam, you will see something like this. You're going to be given a right triangle. That's default. That is the very subject of Chapter 9, but you're going to be given a right triangle. So technically that is one of the 3 angles. You're going to be given another angle. In this example, we're given 25 degrees. Again, you'll see some different value on your final exam. And then you're going to be given one of the 3 side lengths. It is worth noting right here that this 13 unit length, this side HG, this is the specific hypotenuse of this right triangle, the side that's opposite the 90 degrees. So this hypotenuse will come into play. That is a very important designation for a right triangle. But you're going to be asked to solve for the missing pieces. There are 3 missing pieces here. Those will be 10, 11, and 12 on your test. We're going to start with solving for angle G here for number 10. Then we're going to solve for each of the leg lengths of this right triangle in numbers 11 and 12. Okay, well, let's start with number 10. Number 10, you're going to be asked to solve first for the missing angle. In this example, again, the letters don't really matter because in your diagram, it may be labeled completely differently. But in this case, it'll be important to solve for the missing angle, whatever letter it may be. And so for us here, that's angle G. Well, in this case, there's no need for trigonometry whatsoever. We're actually going to be using what seems to be a very well-known concept for whatever reason for math students from previous math courses and stuff like that. And it has to do with the Triangle Sum Theorem. Basically, in every right triangle, every triangle in general, all 3 internal angles need to add to make 180 degrees. And so the simple thing that a lot of people would do in their head is they would simply say, like, all right, 25 plus 90, subtract that from 180, that tells me what's left over for G. And that's absolutely correct. But I do need to see some work, so I'm just going to algebraically represent that thought process. So in this case, I'm going to add the 25, and don't forget that this is, in fact, 90 degrees. So I'm going to add 25 plus 90. And then the piece that I'm solving for here is the angle G. Again, letters don't really matter, but all 3 of these angles need to add to make 180. Well, a simple combination of like terms, 25 and 90 give me 115. And the last step here, again, the piece that many people would just jump to right in their head, is they would subtract this value. This happens to be 115. Subtract it from 180. That tells me what's left over for the measurement of angle G. Doing that really quickly on our calculator, 180 minus 115, that tells me what's left over for angle G. In this case, it comes out to 65 degrees. So on number 10 in your final exam, you're going to be asked to solve for a missing angle. You'll be able to use what's called the Triangle Sum Theorem because you'll be given 2 angles. It is worth noting in Chapter 9, Section 6, we also dealt with solving right triangles where we couldn't start with this right off the bat because we only knew 1 angle. But again, for your final exam, you'll see this scenario. It'll just be a different set of numbers, but this will be how we solve number 10. Simple enough. Number 11. Number 11 is going to be probably the challenging one here in this trio, because in this problem we're going to have to use trigonometry. So in this case, for this example in our notes, we had to solve for the length of side HJ. We need to find the length of this leg right here on the top. That's our next task. And where a lot of Math 2 students tend to want to lean in their strategy is they want to use Pythagorean Theorem. And it's a viable strategy because we're dealing with a right triangle here fundamentally. But we run into a problem. And this is why trigonometry exists. But let me address the problem first. And that's that of the three sides, I only know this 13-unit length. It happens to be the hypotenuse again, which is something that's going to come up in just a minute. But I don't know either the other two side lengths, meaning I cannot use Pythagorean Theorem at all right now. I need two side lengths fundamentally in order to solve for a missing third. I don't have two. I only have one right now, so Pythagorean Theorem strategy is out. Okay. In this case, what I'm going to be doing is I'm going to be using trigonometry. And here's where we enter the infamous mnemonic, Sohcahtoa. Sohcahtoa is a representation of what kind of relationships within trigonometry that we have. S for sine, C for cosine, T for tangent. These are buttons on a calculator. Sine, cosine, tangent. Those are represented by the three operations right here. All the O's, A's, and H's that we get for the O, A, and OA, they're going to be relating to different side lengths in this triangle. So again, let me just communicate that the whole purpose of trigonometry, one of the biggest values here that we get out of trigonometry is that it allows us to relate angle measurement to side length. Angle measurement, degrees to a length of a side. And so in this case, we're going to be able to use the fact that we have this 25 degrees and this 13-unit length in some combination to figure out for this missing side HJ. But then I have to decide which of the three trig ratios I'm using. Well, I always start with the information that I am given. I was given 25 degrees here for angle H, and I was given 13 units for this hypotenuse leg. Let me take a moment to describe again what OH, AH, and OA stand for. O's stand for opposite legs. When I take the sine, cosine, or tangent of something, that something fundamentally is an angle. The opposite refers to what side length is opposite that angle. So for 25 degrees, the side opposite would be this JG side right here. Right? Well, if I'm solving for HJ, this guy doesn't help me, so I'm not going to be using the opposite side. H's refer to the hypotenuse in a given right triangle. This is a specific side, right? The H here refers to a hypotenuse. This is always the side that's opposite the 90 degrees. This happens to be the one other piece of information I'm given here in this triangle. So I'm definitely going to be using the H. The A's refer to adjacent legs or next to legs, all right? So again, if I'm talking about an angle, the adjacent leg here would be this HJ side, the piece I'm going to be solving here for number 11, whereas GJ side or JG side, this is the opposite leg. All right, so let me come back to this. I want to solve for HJ. I'm given this angle and this length of one of the sides. So I'm going to figure out which of these three guys I'm going to use. So if I'm solving for HJ up here at the top, this is what we call the adjacent side to 25 degrees. So I'm definitely going to be using one of these two. The other piece of information I'm given here is this 13-unit length. This is the specific hypotenuse of the right triangle. And so based on that, I'm going to be using an AH combination. Adjacent, hypotenuse, I'm going to be using this guy right here, Ka. The C here tells me I'm going to be using cosine. So now let's jump to the work. That's going to tell me that I'm going to be taking the cosine of what? Again, I'm going to be taking the cosine of an angle. The angle I'm given here is that 25 degrees. This is going to equal a fraction. That fraction is determined by these two letters, adjacent over hypotenuse. The adjacent side length over the hypotenuse length. Well, in this case, I know the hypotenuse length here is this other piece, this 13-unit length. The piece I'm solving for here is the HJ side, the adjacent side. And so in order to solve for adjacent based on this, first off, cosine of 25 degrees, this is just button mashing in your calculator. This is going to be some crazy decimal, but it's just button mashing in your calculator. This 13 being divided into hj, I'm going to move it by multiplication. So let's move to that step next, just to solve for our missing piece here. And that's to multiply the other side by 13. I'm going to get 13 times the cosine of 25 degrees is equal to that hj length. Well, again, this is just button mashing. And what I mean by that is that this is something that I can do on my calculator. I just needed to set myself up with this equation. In my calculator, I'm going to start with this piece first, cosine of 25 degrees. In my calculator, I have to start with the 25 degrees. And when I take the cosine of it, that's hitting this cosine button right here. Crazy decimal, not unexpected, but that's the cosine of 25 degrees. Remember to multiply it by the 13 in this case, and I get the following value. This is the length of hj. You'll be asked to round this to the nearest tenth, so this is going to come out to be about 11.8 units. We've officially solved for the length of hj using trigonometry. The actual math itself was pretty quick. There was a lot of explanation and background information right there, but this is where it comes from. Well, at this point, you're going to be asked to solve now on number 12 for the other missing piece. The other missing piece here is side GJ. And for this one, number 12, you'll have options. So it is worth noting now that this is still a right triangle. And now that I know that 11.8 units is this hj length up at the top, I could use Pythagorean Theorem to say hj squared plus gj squared is equal to the hypotenuse hg squared. So I'd have 11.8 squared plus my unknown squared is equal to 13 squared. Simple algebra would be able to solve for my side length gj. You can totally do that if you're more comfortable with it. But because it is less comfortable for us, I'll go ahead and use trigonometry again for number 12. You totally can. You don't have to. You can use Pythagorean Theorem at this point. But let me continue with trigonometry here just to get us used to it. So now in this case, gj is this side length. So let me use my starting information again, the 25 degrees and this 13 unit hypotenuse. GJ is opposite my 25 degrees. So I'm going to be using one of these two guys because they both have O's. The other piece of information I'm giving here is the 13 unit hypotenuse, meaning I'm going to have to use H. So opposite hypotenuse means I'm going to be using sine. So for the sake, again, of working through this problem, I'm going to use the trigonometry just to get us used to it. I'm going to be using sine here. Taking the sine of what? It's going to have to be a degree angle. That 25 degrees is what I was using. And this is going to be equal now to, opposite over hypotenuse length. Again, just like in the last problem, I do know the hypotenuse length is 13 units. And then the piece I'm solving for here, that opposite side, is the GJ side that I'm solving for. This actually almost looks exactly like what we used to solve for HJ, the one difference being that I'm using sine here as opposed to cosine. And the only difference there is that it's just a different button on the calculator. Well, just like the last problem, I'm going to move this 13 by multiplication, and I'll end up with the following formula. 13 times the sine of 25 degrees is going to equal that unknown side, GJ. Again, this is just button mashing. Let's mash some buttons. So on my calculator, again, I have to start with the sine of 25 degrees. I start with my 25. The sine button is this SIN button. Crazy decimal, not unexpected, but that's the sine of 25 degrees. Just remember to multiply by the value in front, in this case 13. And there's the length of my side, GJ side. Rounding to the nearest tenth, this comes out to be 5.5 units. Quick sanity check here. Couple things to look at. First off, both these, because they're the legs of a right triangle, should be less than the hypotenuse. The hypotenuse of every right triangle should be the longest of the three sides. 13 is bigger than 11.8 and 5.5. That checks out. I could use Pythagorean Theorem here to check out that what should happen is that squared plus that squared should equal that squared. So I could do 5.5 squared plus 11.8 squared. should equal 13 squared. You can check that on a calculator, but I'm out.